Good morning, good afternoon, good evening. Whatever the case may be, we are back and better than ever for part 3 of geometric geometric sequences. And we are going to finish up with a problem, an application problem. We like to call it a probability here. So let's get to it, shall we? All right, so now we have a geometric sequence problem, growth and decay. Our geometric sequences if we have a constant increase, okay, which in this case we will. The initial population of rabbits on a farm was 50. So I know this is important for a sub I, and we are basing this on our geometric sequence formula. U sub n equals U sub 1 times r to the n minus 1. U sub 1 is equal to 50. Okay? And if you think, well, let's just do that first. And r, our common difference, is actually equal to 1.07. And why is that? Well, if I just multiplied by 7%, I would only get the number of rabbits that were that increased. I wouldn't get the total number of rabbits in the population. I will get the number of new rabbits. So I have to add 100% to that, and 7 plus 100 is 107%, and written as a decimal, which we need to in order to operate with it, is 1.07. So now we know that U sub n is equal to 50 times 1.07 to the n minus 1. Okay, so U sub 1 would be equal to 50 times 1.07 to the 0 power, which is equal to 50 times 1, or 50. And we already know that U sub 1 is equal to 50. But we need to do this to figure out which population we, or which term we're going to use to find it for these values. So U sub 2 would be equal to 50 times 1.07 to the n minus 1. So that would be 1 to the first power. And that is the population after 1 week, right? Let's do U sub 3. So that would be 50 times 1.07 squared, and that's the population after 2 weeks. Now take a look at this, boys and girls. The week number is the same as the exponent, okay? So in order to get, let's think about this, after 15 weeks, I need this to be 1.07 to the 15th, which would have to be the 16th term because of the n minus 1. Okay, and I will tell you, if you crank that on your calculator, that is approximately equal to 137.95. Okay, so there were actually 138 rabbits. And you might be thinking, but Mr. B, you can't have 0.95 of a rabbit. You're right. And so you might think, well, we round down. Well, no, you can think of this as if rabbits are born in litters, and so there's going to be, it's going to round up no matter what, to that other rabbit. You can think of a rabbit as part of a litter. It's going to be a full rabbit. So you have to think of it in that manner. So after 30 weeks, then we are going to get, or we're going to need U sub 31, and that's 50 times 1.07 to the 30th power, which is approximately equal to 380.61 if you do that on your calculator. So we can interpret that as 381 rabbits. Okay. So then how long would it take for the population to reach 500? Let me scroll down for part B. Where do I have some room? I'll do part B over here. So part B, I need to take a look at 500 equal to my general term, which is 50 times n, not n, 1.07 to the n minus 1 power. And I can solve that using logarithms. I can do trial and error, or I can find the point of intersection on my calculator, okay, which I'm going to choose to do that. So let's go here and see if we can change this function. You can double click on it, and I'm going to enter in, let's see, 50 times 1.07. And actually, I have to learn from this. This needs to be the x power, not the x minus 1, because that x is going to give me the weak number. And that's going to look like that, which is fine, but we knew we can go out here, expand our graph, maybe out to 40. And our line, instead of this one, we need, we were wondering about 500. And we get that point of intersection. And I could scroll down and see if I wanted to. I'm going to do the point of intersection and just get this over with from the left to the right. And we get 34. We get 34. So with that graph, which you would have to sketch and show on any IB exam, just to show how you got your answer. So you could do a quick sketch. Of course, I have the advantage of being able to copy and paste. To show it, you would not have that advantage. You'd have to sketch it on your paper by hand. So we can say, based on this right here, that it would be 34 weeks. All right, that is it. That is all I have. Let's go ahead and go out with Echosmith with Bright. And with that, I am out. Feeling bright.
And I see colors in a different way.